Hey guys, welcome back. We are continuing what we started yesterday with our slope in a table. So today you are looking at basically some more practice. You should have already gotten the assignment, which is called Identifying Rate of Change in Tables. So looks like this. Okay. So just want to do a little bit of review from yesterday. So I still have it up here. So slope, once again, is our rate of change. So instead of them calling it slope on this worksheet, they called it rate of change. So we have two different types of how we call it, but we are still doing the exact same thing that we did yesterday. Okay, so let's take a look at example 1. Okay, which is technically number 1 on your worksheet. So you've got your X and your Y. You've got -9, -45, -3, -15, 0, 0, 630, and then the last one is 840. Okay? So we are going to do the same exact thing that we did yesterday. So we're going to look for our change in Y, which looks like that little triangle, that delta symbol. So delta Y is change in Y, and delta X is change in X. So once again, they've given us a vertical table, so we're going to start with our Y's. If I'm at -45 and I want to get to -15, I'm going to have to add. And 45 to 15, I'd be adding 30. Okay? So now I'm adding 30. Now this one's interesting. Okay? So this time I've got -15 to 0. I'm only adding 15. This is different. We didn't see this yesterday. So I'm going to show you a little tip on how to still figure it out. So if I do 0 to 30, once again, I'm adding 30, and that's good. And then when I do 30 to 40, I'm adding 10. So even though these aren't the exact same numbers each time, we still are going to see that the rate of change is exactly the same. So if you notice on this side, when I do my rate of change, -9 to -3, I'm adding 6. -3 to 0, I'm adding 3. 0 to 6, I'm adding 6. And 6 to 8, I'm adding 2. Okay? So when I look at these, the difference is that they are not the exact same number each time. So what that means is I actually have to look at each individual one. So if I go from -45 to -15, my rate of change is 30. And if I go over here and use the same X's, my rate of change is 6. So I've got 30 over 6. Okay? So that would simplify to get 5. Now, what about when I go from -15 to 0? That one's 15. And its corresponding X changes by 3. Well, 15 divided by 3 is also 5. So even though they're different numbers, when I simplify them, they end up being the same. Let's try it again. 0 to 30, I get 30. And then 0 to 6, I get 6. So once again, 30 divided by 6 is 5. And then last, I'm going to be adding, I get 10. And this time, my X's are only 2. So once again, I get 5. So every single time I go from Y and its corresponding X, they all end up equaling 5. So you're going to find tables that are like this probably more often than you find those perfect tables we did yesterday. Okay? So my rate of change is going to be 5 for my first example. Okay. let's take a look at our second problem. So, x and y, I get -6 and +6, -5 and +5, 0 and -0. I don't know why they put a negative sign there because technically 0 is not negative or positive, it's 0. 6 and -6, and the last one is 8 and -8. Okay? So we're going to do the same thing, and this time I'm going to do it one by one so you can see each one individually. So my change in y from 6 to 5 would be -1. So before I do all my y's, I'm now going to look at the corresponding x's. So -6 to -5 is adding 1. So my rate of change would be -1 over 1, which is -1. Okay? So I've got a -1. Now let's try the next one. From 5 to 0, I'm subtracting 5. And the corresponding, I'm going from -5 to 0. So I'm going to add 5 this time. Okay? Same thing. -5 over +5. Change in y over change in x is -1. See, you're getting the same slope each time. Your table, though, is not being consistent by showing you the exact same number as you're adding or subtracting. 0 to -6 is -6. 0 to 6 is +6. Forgot to put my plus sign there, so I went back. -6 over +6 is also -1. Okay? And the last one, it should be -1. So I get -2 to -8. I'm subtracting 2. Oh my gosh, I just said that. -6 to -8, I'm subtracting 2. And 6 to 8, I'm adding 2. So -2 over 2 is -1. So each time I'm still getting the same rate of change. Okay, even though it's not the exact same numbers each time, when I do my change in y over my change in x, I end up with a -1 once I simplify. So do you guys see why it's so important that you have to simplify? Because if you didn't simplify, you wouldn't be able to see that they have the exact same slope or the exact same rate of change. Okay? Okay, gonna do one more. So I'm now going to look at number 3 on this sheet. Okay? So I get x and y, -6, -10, -5, -9, 2, -2, 3, -1, and 4, 0. Okay. So once again, just looking at this table, I can see that I'm not going to have the same change in y every time. So I'm going to have to use that method of the corresponding. So -10 to -9 would be adding 1. -6 to -5 would also be adding 1. So I would get 1 over 1, which is just 1. Okay? -9 to -2 is adding 7. -5 to 2 is going to be another adding 7. So I get 7 over 7, which is +1 again. Okay? What do you think the next two should be? Yeah, it should be 1. Let's make sure it works. Okay, -2 to -1, I add 1. 2 to 3, I add 1. So, there's our magic number of 1 again. Last but not least, -1 to 0, I'm adding 1. And 3 to 4, I'm adding 1. So there's my final 1. So every single time I get the same rate of change. Okay? Okay, so I know this is a little bit different from yesterday. Yesterday's were super easy because they were exactly the same each time. But today's, I really have to focus on looking at the change in y over its corresponding change in x. Okay? And that way I can see that the slope is exactly the same each time. So what you are going to do today is you are now going to go back to your sheet. You should have 1, 2, and 3 done because we did them together. You are going to now do 4 through 12. Yes, you can use a calculator. Okay? Please make sure you ask me any questions. Send me emails. Come into my office hours in that Zoom meeting from 2:30 to 3:30. And I will see you guys again soon. Thanks.